Good afternoon, everyone. My name is Peter Bidewell, and I'm the Chief Marketing Officer for Applied Blockchain. So Applied Blockchain is a blockchain solutions development firm. We build blockchain applications for our clients, both big and small, and also provide consulting and training workshops. So today the talk is all about private consortium and public blockchains. So first of all, let me just kind of start by saying about what is a blockchain. I know we've had many different analogies and many different definitions of what a blockchain is, but I'd like to give mine as well. So I could tell you that it's a distributed database, which is replicated across many different nodes, where there is a consensus mechanism whereby transactions are verified and cryptographically signed. Now, the trouble with this, of course, is that that doesn't make much sense to people who are not very tech savvy and understand the technology very well. So instead, let me give you a different analogy. The internet. What we have today is the information web, whereby you can transact information anywhere in the world, instantly and for free. Now, the blockchain is very similar, but let's call that the value web, where you can transact value anywhere in the world, instantly and for free. So that's all it is. It's really, really simple. There are, however, a couple of things that make a blockchain unique and different. And I guess the most important one is that with information, if I was to send you text or some file or something, it's okay that you have it as well as me, right? With value, it's not. Everyone needs to be absolutely sure that the value that I'm sending from myself to yourself has been moved, and I no longer have that value. So to make that work, there is a concept of immutability. And by that, I mean, once something happens, it cannot be changed. This is very important, of course, that you can't tamper with the system. The way that we verify that is by having great visibility across all the different nodes in the same network. So everyone has access to see exactly who has transacted what, at what time, and so on. Now, I say who has transacted what. There is also a pseudo-anonymity around this as well, which means that for any given blockchain, you may be able to see a hash or a specific code that represents an individual user, but you may not understand exactly who the person behind that user is, behind that account. So that's quite important for a public blockchain. So the three different kind of categories that we're going to go into right now are public, consortium, and private. So public could be something like Bitcoin, a consortium could be R3, and private could be a single entity. So an example here is Appy, which is a client of ours. So for a public blockchain, there are a few defining characteristics. One of which that it's open source, which means that anybody theoretically can contribute to the code to improve the blockchain. It's also available for download and for access by anybody who wants to have access to that code base. It's fully accessible, which means that anybody can join the network and begin transacting and moving data around and has exactly the same permissions as everybody else, which means it's absolutely decentralized. There is no central party that owns the blockchain, owns the network, but actually everyone has the same degree of permission or authority across the different network. And finally, of course, it's transparent, which means that anybody on the network can see all the transactions that have occurred, at what time, and there's a full copy of the entire ledger being held by every individual on the same network. So here's a kind of graphical representation of this. We have an unexposed user who is then able to read and write onto a blockchain in a very equal manner, where their data can be stored, signed, and encrypted. With a consortium blockchain, it's quite similar actually to a private blockchain, but I guess the important thing here is about the collaborative nature of research and development. So a consortium such as R3 is a collection of lots of different known members who want to work collaboratively to build out the technology and the solutions. There is limited accessibility here, so only members of the network are able to transact and to work together on the network. And of course, it's then selectively decentralized. So as part of the same thing, only specific people are given nodes to hold onto the full copy of the ledger. Another important point is about identification. So with a consortium, unlike the public blockchain where everyone's pretty much anonymous, in this version, everyone can be assigned an ID to back up the person who they're operating as on the network itself, which means then, therefore, you can see who has done transactions, not just that transactions have occurred. And again, here's a nice graphical representation where imagine you have node A, where they assign a new user, they KYC check them, and that data, that personal information data is stored within a smart contract on the network. That information can then therefore be shared around to many different members of the same consortium. And importantly, a regulator node could be added so that the regulator can have perfect visibility over all the information and the transactions that have occurred in a read-only manner. For private blockchains, the difference between a private blockchain and a consortium blockchain in general is that you have an individual entity that pretty much has developed and owns that network. So this could be a business solution, a web app, for example, where there are a number of different clients or customers that are added to that network. So in that case, again, it's limited in terms of accessibility. Only specific users are allowed to join the network. It's quite centralized in the fact that there is a central entity or organization that pretty much owns the blockchain. They may act as an admin node, for example. And again, there is identification to assign the players on the same network and who they are in reality. So again, here's a nice graphical representation of this, where you may have approved users that can transact data. And I say data here not just in terms of value, because data may be important too. They can sign, they can encrypt, and they can share that information via different permissions around the same network of individuals. There's an admin node at the top here, who may have different permissions and different visibility, the ability perhaps to add or remove certain users. And then finally, there's also the regulator node, again, who has perfect read-only access, which means they have real-time visibility on all the transactions that have occurred. Importantly as well, because this is a shared database, there is no need to reconcile information. All information that is shared is automatically synced across all the different nodes. So just from a business perspective, that's a huge efficiency gain. Okay, let's go into an evaluation of the different characteristics of what happens here. So in terms of privacy, comparing a private and a public blockchain. Now, in theory, the encryption means that actually no information is accessible on a public chain either. You can ascribe and say who is allowed to see what. But ultimately, for a business perspective, the idea that your information, your private business information, is being shared around many different random people, if you like, across the entire world, perhaps isn't the best idea. Even though that information is encrypted, you may want to say, actually, we don't want all our information to be shared and distributed across the world. One option for this could be online versus offline. And by that, I mean you could have a hybrid model where important information is stored securely on a private network, and then that is verified by attaching a transaction onto the public network. So imagine you have this very private interaction of different transactions that go on, but actually then to verify as an audit trail in the future sometime, you can stamp that on the public chain, which is completely immutable. There's also an issue about legality here, and this is true for both public and private blockchains. Because the information is shared across many different nodes, many different parties, if something was to go wrong and the information was leaked or some system went down, who's at fault? Who's to blame? Is it nobody or is it everybody? And these are questions that we're asking right now as to where does the fault lie if there's no central authority that holds all the information. For encryption, there is encryption for both public and private. I think the important thing here is the degree of encryption that you can have on a private chain. For public, yes, the transactions are encrypted and the users are encrypted, but actually the smart contracting concept where you can encrypt the data within a smart contract from a private chain is quite important. And finally, then there's also an identity check. You can KYC users, you can work out exactly who the person or organization behind a transaction or an account is. For scalability, this comes down to the generalist nature of a public chain versus a private chain. So imagine that a private chain has been created purely for the effect of solving a specific business use case or problem. The public chain, however, is intended to be used by the masses, by lots of different consumers in many different ways, right? So actually, it's not designed for a specific individual solution, but pretty much for everything. And this means, therefore, that to grow and to develop that technology takes a long time, because you're building it for everybody, not for one purpose. For a private chain, then, comparatively, if you build the full technology stack from the ground up for, let's say, a drone registry, the technology itself is incredibly similar to another solution, for example, a car registry. And actually, therefore, you wouldn't need to rebuild the entire thing from the ground up, but actually you could just change a very small piece on top and build a brand new solution. The other component is about kind of quantity and usage, so the workflow, the ability of smart contracts to translate business logic into computational logic. And this idea is quite fascinating, so we'll go into this a bit more detail later. But the idea is that anything that you could agree upon in real life, you can translate and put into computational code. So the issue with this in a public chain is that there is a lot of latency. If you're having quite a high demand in terms of the amount of information and the code and the execution, the processing power that is required to run and execute upon a specific action, and that information, that data, is then shared across many different nodes all across the world. Thousands of different nodes have to then execute the same program and run the same code. That's a lot of processing power that is wasted, frankly, because there aren't that many nodes that actually this is relevant for, or that are using this. Which therefore, it slows down the entire system and provides a lot of latency. So a private blockchain, by comparison, you can actually build the entire solution specifically for what you want it for. There is no slowdown, there is no irrelevance in terms of transactions, because everybody that's on that private network has a vested interest. The only reason they're on that private network is because they want to share the information and transact in a certain way, which means, therefore, that you can create and tailor-make that blockchain for the exact solution that you're trying to build, not a general term for everyone to use. So functionality, the public blockchain is built on about a lower level. The idea being that you can provide the platform, the foundation of tech that anybody else can build on top of. The issue with this, of course, is that for any business solution that you're trying to build, any application, you don't have a seamless integration between the bottom layer of the platform and the actual application layer on the top. Comparatively, a private blockchain, you can build the entire stack from the ground up if you wanted to, which means there'll be seamless integration between the top layer and the bottom layer. It's much more efficient, basically. So on top of that, what we've done also is build a number of different feature modules. As there are many things that can be reused and applied to lots of different business cases, it's important that you can build a reusable code framework, if you like. So what we've done is we have modules that include things like scalability, caching and storing of information, permissions, and wallets, things that we can use in many different solutions for many different clients. I think a big one to mention also is costs. So for a public blockchain, pretty much it's open source. You have many different companies that are contributing code and building out the different solutions, building out the different platforms, sorry. So in that respect, actually public blockchains are cheaper up front. The issue comes from the cash flow perspective of the ongoing costs, the transaction fees, the gas that's required to process transactions and process workflow. So on a private chain, you do not have this. You can say, we're going to cut out cryptocurrency, we're going to get rid of all the different transaction fees by using a different consensus mechanism, rather than the very costly proof of work, which most blockchains use from a public perspective. You can cut that out when it comes to private, because there are a bunch of known parties who have a vested interest in making the entire system work and sharing their information. One component to mention though also is maintenance. As a blockchain effectively is a shared database, you have many different parties holding on to the same information, which means therefore that you have multiples of hosting fees to hold and store that information. So this can be quite costly. But of course, again, for a private blockchain, this means that you have a vested interest, you have an incentive to maintain that ledger because actually it's in your best interests and you're gaining efficiencies by doing so. And finally, then the time cycle concept, which is about how quickly you can take a solution to market. If you're waiting upon, let's say, Ethereum to build out certain functionality that you're looking to use for a solution, you might be waiting a long time. As I said before, it's very generalist. They have many different use cases and many things they're developing, but it may not be the one thing that you need for your solution. So in terms of gains, a key component here about the public versus private. Public it is what it is. You may have your own business process, your own operating model, your way of doing business, and that probably isn't the same way of doing business as the platform that you're working with is built for. Comparatively, if you have a private blockchain, you can build out the technology in exactly how you want to build it, which means you can tailor-make that tech stack according to your exact business process. In reality, then, this means that you're not changing anything. You're doing business as you normally do business. You're identifying the issues or the problems where blockchain can be the solution. And then finally, there's marketing. Now, it shouldn't make a difference, but it does. If you are a bank or a consortium of different banks, and you're telling your customers that all their data is stored in a public network that anybody can have access to and can look at all the different transactions that have occurred. Now, it shouldn't make a difference because actually the information is encrypted, it's stored, it's pseudo-anonymous. But to market to someone and say, we have a private network, which means that all your information is only accessible behind a number of existing firewalls and existing security tests that we've already got implemented for our non-blockchain solutions, you can have exactly the same concept, all the efficiency gains of having blockchain, but still maintaining that security level from a marketing perspective. And the final component here is about support and control. So with initial coin offerings, you've got the ICOs where any new cryptocurrency can issue a large number of their coins, where people buy into this new cryptocurrency, and then the founders of this organization get lots of money as an investment to then build out the solution and build out the platform. The issue with this is that if you think of coins such as Bitcoin or Ether or anything else as a form of a stock or a share, it's the same kind of concept. It's an investment that you want to hold on to as it increases in value over time. If you try and liquidate that coin or that stock too early, you're wasting that investment. So there's a huge disincentive for the founders of the organizations that issue these coins to liquidate back to cash, which means there is a restriction on cash flow for investing further into developing the network and the platform. By comparison, any private network operator, so again, an entity or a consortium, have a vested interest in making sure that network is built as quickly and efficiently as possible. They have an expected return on investment, otherwise they wouldn't be doing it. Right? There is no building tech for the sake of building tech. The aim of this is to build a solution that solves a real business problem and then making money out of it. And finally, it's controllable. One of the biggest problems with a public chain is that everything comes down to a democracy. The entire concept is a consensus mechanism where any decisions on the future direction of development come down from every single different player in the same space agreeing upon that change being made. If they don't agree, it doesn't happen. Now, as a business owner, do you really want to rest all of your investment on the hope that a bunch of people from around the world are going to decide something in your favor? It's quite a dangerous thing to do. By comparison, building a private blockchain, you can have absolute clarity and absolute control over the future direction of where you want to develop further next. So a quick overview of what we just talked about. Looking at public blockchains in general, they are very open, they are very generalized, they're being built to cover many different aspects, many different possibilities for many different users. There is a medium upfront cost, but a consistent overarching cost. And in general then, there is, in terms of support and control, it's a democracy where an individual business doesn't have much of a say. By comparison, a private blockchain is retained only to known users. It enables a large amount of workflow in translating that business logic into computational logic. And ultimately, there are reduced costs because all you're really worried about here is the maintenance costs of hosting rather than transaction fees. And finally, the most important thing here is if you're investing money into something, you want to make sure that you have the control over the development of that technology. Just a couple of really important points also that I haven't mentioned just yet. Cryptocurrency is something that is looking to be regulated. There are movements now in terms of regulating the exchanges of cryptocurrency, and this is a number of different legal issues. So using a public blockchain means you have to use, well, pretty much you have to use the cryptocurrency that goes with it for value exchange. This has a problem, because not only can you just experiment in a new market and try a new solution, but suddenly then you're having to answer questions about regulation and about the movement of currency. And some of the other points we mentioned before about transaction costs, a loss of control, and generally a limited capacity for that workflow. Private chains, by comparison, then, require no proof of work. There can be different consensus mechanisms that could be used. And there's no need for mining or a cryptocurrency at all, which means you can operate all the efficiency gains that you would get from a private blockchain without the need to be regulated or all the other problems that come along using cryptocurrency. So in general then, I think it's quite obvious, my preference on this. We work predominantly with private blockchains. We can work with public blockchains, but we advise against it for the time being, purely for a specific business solution. Now, there are use cases, of course, of public chains when it comes to cryptocurrencies from a consumer perspective, but when it comes to a business application where you're looking to solve a problem with efficiency and information sharing, for now at least, a private blockchain is much more suitable. However, we do see there being a similar trend as we've seen with the internet. Now, in the beginning, the internet was attempted to be owned by a few specific companies. You had companies like AOL and CompuShare and a few others that tried to own the internet and privatize it. By comparison then, what happened afterwards, you had this complete opening of the internet, and suddenly everybody was able to use it. I think there's the same trend we're going to see here with blockchain. Right now, there are a few companies trying to build the best platform that everybody will use and they can own. I think that's not going to be the case. I think eventually there will be this opening of blockchain and a kind of universal standard of blockchain that is adopted by the world. So let me tell you a bit more about what we do and how that all ties together. As I said before, Applied Blockchain is a blockchain application development firm. So what we do is we build out blockchain solutions, private blockchain solutions for our clients. We do this by a number of different methods, but one of which is a framework that I'll tell you about in a second. On the back of having an in-house team of expert blockchain developers, we understand the tech and the very kind of cutting edge of what the technology is able to do today. From this, we're able to have training workshops to explain the principles of blockchain, and then we can also consult on how that information could be applied to your specific business. So what we've done, we've realized that at the moment there are many different platforms, right? You have Bitcoin, you have Ethereum, you have Eris, and a number of different of these kind of organizations that are trying to kind of own blockchain. Ethereum, perhaps not so much, it's much more open source, but many of the others are trying to effectively own the concept of the bottom layer of the technology stack. Now, we realize this probably isn't the best way of doing things. If you're building out applications for clients, a very dangerous thing would be to try and pick a winner in such a young and infant market. Inevitably, in such a new space, there will be a very small number of winners and a very large number of losers. It's very dangerous to try and pick the winners now, when frankly just no one knows. Our platform of choice at the moment is Ethereum. We think it's the most mature, and it has the best capabilities for what we're looking to do. But who knows? In 2 years' time, Ethereum might not exist at all. It might be completely replaced by something else, like Hyperledger, which may emerge as the more dominant platform. We don't know. So what we've done instead is we've built a framework that sits on top of all of these underlying platforms, where upon this we can then build applications, right? So this framework means that you can switch out any underlying platform easily from one to the other. So you're not bound to a single platform, but instead you're future-proofing solutions, whatever happens. So as part of that then, we also have a number of different modules that we've included. These are things like privacy, about data caching, and permissions as well. The aim of this is that there's a huge gap between what the technology is able to do and what businesses want the technology to do. And we're trying to bridge that gap by building out a generic framework of different modules that can be plugged in as and when. So we work with both corporates and also startups. The corporates we work with, we're looking at the kind of the next questions. And I think I mentioned this briefly in our panel discussion yesterday. But rather than just focusing purely on what the technology is capable of right now, we're looking actually at the next questions and saying, okay, well, the technology is doing what it's doing. We're building what we can. But what happens then when you try to implement a blockchain solution in the real world? There are issues of legal, there are issues of compliance, of security, and also in terms of scaling up. So we're at the moment building out different modules and different solutions to answer those questions. Right now, for example, a big one is about enterprise integration. It's how are you going to merge that blockchain solution into the existing system that you already have with your business? It needs to work perfectly seamlessly. The other area is with our startups. Now, for me, this is the most exciting area, purely because they have some of the more interesting stories. Our larger clients often are a bit slower, and they only do very small proof of concepts or small kind of testing the water pieces. By comparison, the startups we work for, we're building the full technology stack from the ground up. And in this, we're able to help them with a number of different areas. This could be intellectual property registration. This could be talking with the Financial Conduct Authority to make sure that they are compliant and that their solution can actually be used by real customers in a regulated market. So very quickly, I just want to go into a really interesting concept that we've been thinking about recently. The evolution of blockchain actually kind of mirrors perfectly the evolution of exchange of value over time. So if we look at the left-hand side here, we have verbal contracts. So thousands of years ago, if you wanted to exchange something with somebody else, or if you wanted to agree upon something, you'd have a verbal contract that said, if I do this, and you do this, and that's it. We then moved into an asset exchange concept, where you'd have, if I swap my cows for your chickens kind of model. And this worked for a while until we realized that perhaps carrying hundreds of chickens around wasn't perhaps the best way of doing things, which then we invented currency. And the idea that you could then transact using coins. But if you think about it, currency is an invention. We've invented this concept where this piece of metal or a piece of paper is worth something and can be exchanged. The entire principle, therefore, is that it's a piece of value that we can agree upon of a certain price. We then invented digital currencies. So this is Bitcoin and others, where you can transact value across the internet. Now through blockchain, we're also able to have the asset ownership concept, where I can transfer the ownership of my house to you. And then finally, we have smart contracts, where agreements and logic-based transactional process can be agreed digitally and executed. So I think it's just really interesting looking at that spectrum of how you've gone from the kind of core concept of value exchange, and we've gone to an invention and then back to effectively what the core is. And only through blockchain can you have this ability of an open marketplace across the entire world for sharing both value, data, and also workflow. Let me just give a quick example of Bitcoin versus Ethereum, or perhaps any other platform of Ethereum's type. Bitcoin is a bit like a calculator. So a calculator, you have a series of inputs, and then you get outputs. In effect, you have a transaction-based process, right? It's very straightforward. You have numbers that go in, numbers that come out. By comparison, Ethereum is a platform, a bit like a smartphone, where you can build any application on top of this. Right? The idea here is that it's not limited. It's not input-output. Anything you can imagine that you could code into a computer, you can do the same thing with Ethereum. It's a Turing-complete programming language. So, as I said, we're quite big advocates for this. There's a few different reasons why Ethereum is quite so good. An important point to mention, by the way, about the private versus public, private blockchains do not necessarily have to be purely developed from the ground up. Many, if not all of the solutions that we build come from the public Ethereum code base, upon which then we build additional solution and application functionality. So actually, you're getting all the benefits of a public platform, which is used by thousands of people across the world, millions of people across the world. And in doing so, then, you have this battle-tested technology. You're not building something and hoping that it will be secure. You're using something that's been used across the world that holds a lot of value that people have been trying to break and hack for years now. Perhaps the most important and interesting one out of the Ethereum feature list is about smart contracts. So in this, there is the ability to store data, to provide permissions as to who is allowed to see what components of that data, and take action, so it could be read-only or read and write. There is a workflow capability where you can have a logic-based, if this, then that, which means you can agree upon certain business actions that could happen and translate that into code. Now, you can tie all those together into many different smart contracts that become effectively an entity. And I think we mentioned yesterday about the DAO concept, the Distributed Autonomous Organization. Purely what this is a collection of different smart contracts that enable lots of different processes to be automated. And for a business perspective, this saves a lot in terms of efficiency. And the final component of this is token transfer. This is an interesting one because the concept of token transfer removes the necessity for cryptocurrency. You can use a token to represent value and fiat value for that, which means therefore that you may have a self-executing smart contract that says, if these criteria are met, initiate a payment in the real world. It doesn't have to be using cryptocurrency. Okay, let me go into some examples then of some clients that we're working with to give you a bit of a flavor of what this could mean. Okay, so again, moving one step further than just purely the idea of payments, these examples are meant to demonstrate that yes, there are payments involved, but also the concept of this shared distributed ledger of information that can have self-executing contracts and workflow built in. So BAB is what I think is the world's first blockchain-based bank. And the idea of this then is that the bank is built for the developing world. So using biometric data capture, so eye scans, finger scans, and so on, you're able to capture the identity of a human being. Now imagine in Africa, someone who doesn't have a birth certificate or a passport, and they have no form of identification in a physical manner. You can then capture the proof that they are a unique human being. That's all you need. They're a unique human being. Using that then, you can do two things. By onboarding this new customer to a bank, you're giving them first, an identity that they've never had before, and second of all, financial inclusion. So you can KYC that individual and make sure they are a unique human being. You can store their personal data inside of a smart contract and encrypt that data so only that user has the ability to view and use their own data. Now, this is a really important point, the identity piece. Why is it the case that you give all your information away to every single person you meet? Every time that you log in to something, you provide where you live, what your age is, what your name is. Every time you go to a bank, every time you go to a restaurant, it could be anywhere. You give all your information away. And that doesn't make sense. In fact, it should be the way that every individual retains their own information, which has value, right? It's valuable information. It's your behavior, it's what you do in your life. You retain that information, and then you decide who's allowed to see what components of that information. So what this means then is that BAB, as a bank, is not a central bank as we see today, but instead it is a platform supporting the interaction between many different players on the same network. So a user may want to transact information or transact value and move money from their account to another user's account. But also they may want to have the choice to choose which providers from banking services they want to work with, rather than the bank deciding this is the mortgage provider you're going to be working with, or this is the credit card you're going to have. Instead, it's down to the customer to say, I want to share my information in the right amount with this credit provider, who can then provide me with a quote. I'm going to do this 10 times with 10 different credit providers, at which point then I can choose out of this app store of banking which people I want to work with. The point here, of course, is that the customer is the center. The customer is the bank. Another interesting example is CETA. So CETA is an international aviation authority. I think their revenue last year was 1.6 billion. So they're a large company that no one's probably heard of. But CETA, what they're doing that's quite innovative here is that they are utilizing blockchain technology for drones, so for the UAVs. So the issue with drones right now is that no one knows quite where they are, where they're flying, who's operating them. And through a blockchain solution, you can have a record, a shared database of drone manufacturers, drone operators, and also the drones themselves. You can then capture the data as that drone flies through the sky on a map and see the exact flight path of that drone in real time. That data can then be collated, so you have a picture of all the different drones flying in the sky. Now, this may seem a bit early, but of course, in maybe 10 years' time, 20 years' time, and suddenly there's loads of drones in the sky, this could be important. The final component is about the regulator. So from a regulatory perspective, it's very important that they can see all the drones that there are, where they're flying, if they're flying into restricted airspace, for example, at any one time. Now, this is the world first in terms of visibility from a regulator to actually have perfect real-time visibility on something like this. We've also been working with a tier 1 South American bank, and for them we implemented a solution for KYC. So across a few different players in a consortium model where customer KYC data needed to be shared and distributed via permissioned blockchain. This was a great solution. So this solution linked into a national registry of customer data. And together then you could have great visibility and sharing of customer KYC data. The final example I want to give, which is a very simple solution, but something that I think is a good example of almost the next generation of blockchain, is a company called Signatize. Now, Signatize is a signatory list platform. So imagine in corporations where you have a number of directors who are allowed to sign off on various things, right? It could be expenses, it could be contracts, whatever. Right now, the model is that you have a physical piece of paper where all the different directors of a certain company sign their name. So that page is then verified by somebody, which is then collated, pulled together, scanned, copied, and then emailed around all the different members of a certain group. So you can imagine the administrative burden of having to keep up with any different directors that may have left the company, new directors that have joined the company. This entire process has a team of people in corporations who their full-time job is purely reconciling this information, copying it, sharing it, and keeping up to date with who has that information. The issue with this is that these records, these pieces of paper, are often only updated every 3 months or 6 months, which means that if someone leaves the company and then carries on signing their name against many different documents, there's a huge implication for fraud. The solution, therefore, purely provides a platform where you can upload a signature onto a user's account within a smart contract. That information can have permissions as to who's allowed to see what across different companies. You can then also remove or add new users in real time. And because it's a shared database of information across a group of different known parties, there is no reconciliation. There is no team that need to keep up and sign off in different pages and scan them again and send them again. It's all automatically in real time. So as a final thought, there are a couple of future developments that I think are worth noting. I think I've already mentioned enterprise integration, but for me this is a really big one. And it's not just the concept of the first step, which is to make sure that all blockchains are built on the same tech and therefore can integrate and work with each other, but also the concept that you'll have integration between blockchain and non-blockchain solutions, so that a blockchain solution doesn't stand alone and has to be separate from everything else, but rather it integrates and works seamlessly with everything else inside of your company. Another component is identity. As we said about the bank, it's really important to have the concept of your own identity to be maintained within yourself. A great example of this is if you went to a hotel. There's only two things that the hotel need to know about you. Number one is that you're not a terrorist. And number two is that you've paid. Right? In fact, they don't even need to know your name. Right? So using this kind of solution where you can distribute and provide permission as to who's allowed to see you and what parts of you and your data, it's the future. And a final example is about the Internet of Things. Now, imagine you have a delivery drone. Let's say it's owned by Amazon, and you have a vending machine that provides chocolate. Now, both of these devices are connected via the cloud through the Internet of Things. They can talk to each other. They're smart devices. So the vending machine realizes it's running out of chocolate. It sends a message up to the cloud requesting bids for delivery drones that can provide it with chocolate. Using smart contracts, it can determine the best deal out of perhaps 10 different providers of chocolate. Upon confirmation of a single deal, a delivery drone picks up the supplies and flies across and delivers that chocolate to that vending machine. The payment then is initiated based upon the receipt of that chocolate, and the transaction takes place directly between the drone and the vending machine. So of course, you can imagine this is a very simple idea, but now imagine you have thousands of drones, thousands of vending machines, and you have each of these different devices have an identity that is assigned to an organization or an individual. So I think the next development in Internet of Things, combined with artificial intelligence, combined with blockchain, will be a really interesting future development. And that's me. Thank you very much for your time. Any questions?